In number 10, we're going to set up a proportion so that we can solve for the missing side here. And a reminder, we're looking at two triangles that we can compare ratios from. One of those triangles might be this largest one. But then because we've got that altitude, we could also take a look at this smallest triangle in here, or maybe this medium-sized triangle here. So I've got three different triangles, and those triangles may have different sides that are given to us. So if you look at, well, first of all, we know this, the hypotenuse of the large triangle is 100 there, and this part in here is 36, which means this other remaining part is 64. If I look at the largest triangle, I have the hypotenuse of 100, and I also have this short side of that triangle of x. So I've got two things that I could use in that largest triangle. If I look at the smallest triangle, I've got the same thing. I've got a hypotenuse given to me, and I've gotten the short side given to me. If I look at the medium-sized triangle, I really only have one side that I could possibly use. So I don't think I'm going to use that. Instead, I'm going to use the small triangle and the large triangle. And so as I set up my proportion, I want to be able to identify which one goes where. So I'm going to put my small triangle here as the numerators, and that largest triangle, I'll put those values in the denominator. And then which sides in those triangles are given to me? Well, I've been given information about the hypotenuse, and I've been given information about the short side in those two. So now it's just a matter of filling in the blank once I've got that template kind of set up. So let's take a look at the small triangle. That's this guy here, and I want to know what the hypotenuse is. Well, that's the value of x that I'm trying to solve for. And then if I look at that small triangle and try to find the short side, that's the 36 here. Now I'm going to go to the denominator and do the same thing with what's given to me for the large triangle. So in the large triangle, the hypotenuse across from the right angle is that whole thing, which is 100. And then if I look at the large triangle short leg, that's x. Okay, so I've got my proportions set up. I'm comparing the ratio of two triangles that I know are similar, and so now I can just cross multiply in order to solve for x. So that becomes x squared, and then I've got 36 times 100, which is 3,600, and I'm going to take the square root from this side so that x is all by itself, and if I do it to one side, I've got to do it to this side as well. Square root of 3,600 is 60. Technically, it's plus or minus 60 if we're doing it algebraically, but this has to be positive. It's a distance, and so therefore x is 60. This side of the triangle is 60, and if we wanted to go further, that might help us solve other parts of it as well.